Okay, so here we have 10 men and 12 women, and we want to compare this observed mean difference. Is a true difference or is a sampling error or observation error? So we're gonna follow the same logic with the repeated or related t-test we discussed in last week. So first we're gonna create a new data set of the differences between men and women. And then we're gonna set up the null hypothesis and alternative hypothesis. Exactly same logic with the repeated t-test. And following the same logic, we're gonna build a sampling distribution of the mean difference, right? So if we follow the same logic and the same procedure, we want to calculate the mean and the standard deviation, the standard error of the sampling distribution, and then calculate the t-value for our observed mean difference, right? So that is the logic we should follow if we kind of adopt the same procedure with the paired t-test. But we have a bad news here. Let's see what it is. And this is the equation we use to calculate the t-score for our observed mean difference here, right? And let's work through this equation altogether. So we know that the observed difference here, the number we should plug in here is the mean difference we calculated for our two samples, right? So back to the previous slide, we should plug in this number. That's the mean difference between these two groups. And then we are comparing this mean difference with the population, which is 0, because we assume that there is no difference between men and women, which is our, null hypothesis. Okay, so far everything seems alright, right? But let's continue talking about this denominator where we're gonna have some problems. So first, let's talk about this n, this sample size. So for one sample, for the men, we have 10 participants in our sample. But for women, we have 12 participants in our sample. So apparently, these two samples, they have different sizes, right? So we have no idea which n we should use, whether we want to use 10 or 12. It's a question here. And second, because we have uneven sample size, we cannot simply calculate each pair's difference, right? Remember, in the related t-test, each individual will provide 2 data points. So we simply cannot find the difference between these 2 data points. But for this case, we have 10 men in one sample, we have 12 women in another sample. So it is impossible for us to calculate the difference for each pair because we have uneven number in each sample. So that's the second question we have here. With all these questions, it is impossible for us to calculate this denominator for this t-score. So we have to kind of find another way to estimate this standard error to find this denominator for t-score. So in next slide, I'm going to talk about the procedure, how we calculate the t-score for these two samples. The first step, as always, we want to build the null hypothesis. Our null hypothesis is that men and women do not have a different, do not have a significant different number of sexual partners in their lifetime, right? So we have mu x equals to mu y, or we can phrase it in a different way. Mu x minus mu y equals to 0. And the alternative hypothesis is that they have a significant difference in terms of partners between men and women. So mu x is not equal to mu y. And second step, instead of building a mean difference, we want to build a sampling distribution for men and women respectively. Okay, remember we have 10 participants in the men sample and 12 participants in the women sample. And then we want to kind of build a sampling distribution for men's population and do the same thing for the women's population here. So these are the two sampling distributions for men and women respectively. And next step is we want to calculate the mean and the standard error for each of these two sampling distributions. Okay, so this is a table we want to work with. So this column shows the sampling, some kind of characteristics of the sampling distribution of the mean for the group of men. And this column shows the sampling distribution of the mean for the women population. Okay, and last one is the sampling distribution of the mean difference between men and the women. So let's focus on this first two column first, and then we're gonna talk about the third column. So this first row, I'm gonna kind of find the mean for these sampling distributions, and the second row, I'm gonna calculate the variance for this sampling distribution of the mean. Okay, and you know how to calculate that, right? According to the central limit theorem. And last row is the standard deviation of the sampling distribution. We also call it a standard error. So the last row is a standard error. So let's work on these 6 cells first. So the mean for a sampling distribution will be equal with the mean of the raw population. We have learned it from the central limit theorem, right? So we say that the mean for men's sampling distribution will be equal with the men's population here. And same thing for women. Variance, let's kind of skip this part first. I will come back to this variance later in a few seconds. Let's talk about this standard error first. So how to calculate the standard error for sampling distribution? That is, we have learned it from the central limit theorem. We can estimate it from the sample's standard deviation. Okay, so the equation we want to use here is the sample's standard deviation divided by the positive square root of the sample size. Okay, so for men, the standard error of their sampling distribution is this sample, this 10 men as a sample, their standard deviation divided by the positive square root of their sample size. And we do the same thing for this 12 women. And the variance is simply the square value of this standard deviation. So we just kind of take the square value of this equation, and this leads us to this equation here. Okay, I think it's pretty straightforward. Okay, so we have worked out these 6 values for these 6 cells. It's pretty easy. We have learned it before. Next step, we want to work on these 3 cells and calculate the numbers. So this last column contains the information about a sampling distribution of the mean difference between men and the women. Okay, sounds really complicated. What is this population? Let me explain it very briefly for you guys. But I guess most of you have figured it out because we have done similar things before. So let's say we have a population of men, and we also have a population of all women. And we're gonna draw 100 samples from this men's population. And at the same time, we're gonna draw 100 samples from this women's population. But please note that these samples, they don't have to have the same size, right? We could have 50 participants in men's sample, but 100 participants in women's sample. Okay, so we don't need to have the equal number sample size. So no matter how many men and women you have in each sample, the next thing is you want to pair them up, right? You want to calculate the mean difference. So because we have 100 samples for men and 100 samples for women, we're gonna obtain 100 mean differences, right? So we're gonna plot all these mean differences in a new distribution. And this new distribution, we call it sampling distribution of the mean difference between men and the women. Okay, so this is a simplified understanding or interpretation of this sampling distribution of mean difference between men and women. And I hope I made it clear. So after we have we have learned the behind the meaning of this distribution, we're gonna work on these 3 cells, calculated numbers. So the first cell is we want to put the mean difference here, right? That's very simple. We simply put the observed mean difference between our men sample and the women sample. Remember, our 10 men have, on average, they have 8.9 partners in their life. And the 12 women we have as our sample, on average, they have 6.58 partners in their life. So we want to find the mean difference between these 2 values. And we have 2.32 as the value here, right? And next, I'm going to talk about how to calculate this variance for this sampling distribution of the mean difference. We're going to use something called this variance sum law here, okay? So according to this variance sum law, this variance is simply the sum of the variance for men's sampling distribution of the mean and women's sampling distribution of the mean. Okay. So again, so how to calculate the variance of this sampling distribution of the mean difference? We simply, according to this variance sum law, we simply add this number with this number. Okay. And then how to calculate this, the standard error for the sampling distribution of the mean difference. We just take the positive square root of our calculated variance. Okay, so that is how we calculate these 3 values here. I think it's pretty easy. You just need to use kind of something or kind of follow a law called the variance sum law here. And what do this value mean for this sampling distribution of the mean difference? I'm gonna kind of give you guys a visualization to have a more direct and intuitive sense about the meaning of these values. Okay, so let's look at this corner of the slide. So here is the sampling distribution of the mean difference between men and the women. Okay. And the mean of this sampling distribution is equal to the population's mean, right? That is mu x minus mu y. And the one standard deviation of this sampling distribution is this value here. Okay. So the next step is we want to see where our observed difference between men and women falls in this sampling distribution of the mean difference. So let's say if our observed mean difference falls somewhere here, we claim that the probability of getting such a large number is very unlikely. So we're gonna go back and question the null hypothesis we just built and then reject the null hypothesis. But if our observed mean difference falls somewhere here, okay, somewhere here in the center of this distribution, right, within this range, we say, we're gonna return the null hypothesis because the probability of getting such a score is pretty high. So we're gonna return the null hypothesis. There is no problem with the null hypothesis. So with that being said, the next step is how to calculate the probability value. We have kind of we have done this for a lot of times. So in order to know the probability value, we want to compute the t-score. We want to standardize the our observed value, and that is our next step we want to do. So for the first part of our slide, I just kind of